In today's session, we are going to discuss about creating tables. So generally creating tables is nothing but we do some sort of calculations with the given data and we'll generate a report according to the given template. Template as in like mock report or mock shell we call it as. Okay. So now here we have a mock template or mock report. So here they have given for us the data in a Excel document. Okay, so see here. So here this is the data. DM is the data that they have provided us, and with that data you have to create a table called demographic summary table. Okay, with that data that they have provided, and now see. So here this is the template. Not necessarily that whatever values that we have here, we should get the same values, but it is just to get an idea like how the report should look like. They have given for us this mock report. Okay. So now see here, let us have a look at this mock report to understand the report more clearly. Here, see, whatever data that they have used for creating this particular report, I think in that report they would have 3 different treatments. Okay. So all the 3 different treatments we should get as headings. And then this is nothing but the total. It could be the combination of all the 3. Okay. Now, see, in the data that whatever they have used to create this table, I think there might be variables like age categorization, gender, race, ethnic, age, platelet count. These could be the variables. Okay. Now, age categorization. So in this age categorization variable, this could be the data values less than 65 and greater than or equal to 65. So now here this is nothing but the count. N is nothing but always the count. Okay. So this particular value is nothing but count of the total population who have taken treatment A. Count of the total population who have taken treatment B. Count of total population who have taken treatment C. Okay. And total count of the population. This total is nothing but total count of the population. Now coming to the here, this part, less than 65 age group. Okay. And this is treatment A. So this value will be count of the total population who have taken treatment A and falls under less than 65 age group. And same here also, count of the population with less than 65 age group and have taken treatment B. This is also the same concept, okay? And this particular value is nothing but the percentage. So percentage of less than 65 age group with treatment A. So how do you get this percentage? The count of the population with less than 65 age group who have taken treatment A divided by total count of population with treatment A. So 192 divided by 1113 will give you this particular percentage. Okay. Now here also same. Suppose if you take this particular value, it is nothing but cross tabulation. See, white. So this 1038 is nothing but count of the total population whose race is white and have taken treatment B. And this is nothing but the respective percentage. How you will be getting this percentage? 1038 divided by total count of treatment B, which is 4 ones. So now these are the values we have to derive out of the given data. Now this particular value is nothing but age, and for this age variable you have to calculate these all the statistics like what is the total count. Okay, N is nothing but total count, right? And then what is the mean, median, standard deviation, minimum, maximum, all these values you have to. For platelet count also same statistics you have to calculate. So now in order to derive these particular values, what are the procedures should we use? So to derive the count and percentage, we can use proc frequency. And to derive the other statistics, we can use the procedures, either proc means or proc summary or proc univariate. Okay. So whatever procedures that we feel comfortable, we can use it. And coming to this particular total, this 596 is nothing but, so this value is not a cross tabulated value. It is just like one table, one-way table report. So one-way table has a count of the population with less than 65 age group. Okay. So it is not cross tabulated with any other data. Similarly, this particular value 1324 is nothing but total count of the male population. This is total count of the female population. So it's like a one-way table, one-way tabular report. So now, according to the required output, let us write the program and transform that output into this pattern. Okay. So generally, when we do the tables, we do like a lot of calculations and lot of data transformation in order to achieve the given template pattern. Okay. Now let us start step-by-step process. So what is the very first step that we should do? First, we have to bring the required data into SAS. So how to bring that required data into SAS? So here we have this particular output in an, here we have the given data in an Excel file. So let us bring that Excel file into SAS. So how do you bring that? By using proc import. Proc import data file equal to file. Okay. Here you give the path of the file, then out equal to. So under what name you would like to create? The BMS will be in. So data file, copy the path. Okay, open DM. See. So here we have so many variables, but let us not consider all these variables. Whatever variables that we require, only that part we will be considering. According to the given template, what are the variables do we require? This age group, gender, race, ethnic, age, platelet count, and treatments we require. Okay. So race, sex, age, ethnic, age group. Here we have 4 different variables for treatment. One is TRT01P and the other one is TRT01PN, TRT01A and TRT01AN. So P is nothing but planned treatment and A is nothing but actual treatment. Okay. So whenever we refer to the SDTMs or ADaM datasets, we'll find planned treatment and also actual treatment. So planned treatment is nothing but what is the treatment that they are initially planning to give a subject. Okay. Actual treatment is nothing but what is the actual treatment that they have given to the subject. See, so in most of the cases, planning and actual will be equal. But in a very rare cases, you know, like in last minute changes, if there are any last minute changes, then the planned might, the actual might differ from planned. Okay. Suppose say that there are 2 treatments A and B, okay, and they are like 5 subjects. So okay, 3 subjects, and suppose say initially they have planned to give, okay, like this, treatment A for 101 and B for 102 and 103 patients. Okay, so this is like planned, but in most of the cases planned and actual should be equal, but if there are any last minute changes, they might change it like this. Okay, so for 103 instead they have planned to give B, but actually they would have given A. So when we do like any kind of analysis or when we generate any kind of reports, we'll take the actual value, not the planned value. Okay. So P is nothing but planned, so leave it. A is nothing but actual. So here for actual treatment also you have both theoretical value and also a numeric uh, value assigned to that theoretical value. Okay. So generally you can consider any value, it doesn't matter, but instead considering a character value, it will be good if you consider a numeric value, because in case of sorting the data, numeric value will be more convenient than a character value. So let us consider actual treatment, numeric value. And the next one is platelet count. This we want, no? PLT, CNT is platelet count that we want. And the other variables we don't require, so hide them. So finally, these are the variables that we require to create the given tabular report. Okay. Now, let us make the list of those variables what we require. So there is age, ethnic, is ethnic, age, GR1, TRT01AN, age, GR1, PLT, CNT, then CNT, TRT01AN. These are the variables we require. So now what we'll do is close this. I'll create a data set called DM1, set from DM. Okay. Then keep only the variables that you require. Then now execute. See what is. Now this is our first step which is done. Now here we have to calculate this particular counts, right? Which are cross tabulated counts. So count of less than 65 age group population who took treatment A, and then count of greater than 65 age group population who have taken treatment A. So cross tabulation of the count. So how do you get that cross tabulation of the counts? See. So less than 65 age group, treatment 1 count. Greater than 65 age group, treatment 1 count. So less than 65 age group, treatment 2 count. Greater than 65 age group, treatment 2 count. Right. So how do you get that cross tabulation counts? We can use frequency, right? So I'll write here count and percentage calculations. Okay. Now, proc frequency for which data? DM1. Okay. Now table. Tables for which two variables? So first we are considering age group. So age group star treatment. Okay. I'll create the output data set. Okay. I'll create the output data set. Not print. Now out equal to any output data set of your choice you can create. Age group, I'll give age group count. Okay. And then run. So we want only the count at this stage. So percentage we can calculate only when you calculate this total count. Right. So at this stage we want only this particular count. So keep only count. Now execute this and check the output. See, no, 1 second. Frequency count we are getting, but what about the treatment values, like age group values? What about the age group values? We should get like less than 65 age group, how much, and like greater than 65 age group, how much we should get now? Okay, keep only count we are writing. So that's the reason it is keeping only count. Keep only, rather than writing keep, we can ask draw percent. Okay. See, so less than 65 age group, how much count? Greater than 65 age group, how much count for each treatment? Okay, so this we are getting. So percentage we will be calculating. Now, here if we observe, what are the counts did we get? Only for this part, till this part we got the count, right? Not the total, only till here we got it. Okay. So now, in the same way, let us calculate for gender, race and ethnic also. The cross tabulation counts we'll find out. So how to find them? Include those many table statement. For what all variables? And race. Here I'll give them as gender count. Okay. Then ethnic, then race count will give. Okay. Execute now. Open all the data sets. See, open race. See, we got all this. It's good. So now let us calculate the total counts. Total counts are nothing but without any cross tabulation. You know, as in less than 65 age group, the total count. Greater than 65 age group, total counts. So which means without any cross tabulations, you have to calculate. So how do we do that? Just remove the cross tabulation, so that you will get, I'll write here total count. Okay. Now I open so that you will get an idea. See, without any cross tabulation, only that less than 65 total count and greater than 65 total count. Similarly, Hispanic, non-Hispanic total counts you are getting. Okay, cool. Now, what is the next step that we should do? Let us calculate this particular count. So what is this particular count? Count of the population who have taken treatment A, count of the population who have taken treatment B, and then the total count of the population. So I think we can calculate those counts through SQL programming quite easily. I mean, even prop frequency also you can use it, not an issue. But in this case, SQL programming will be a lot more easier than prop frequency. Okay. So prop SQL, select, okay, select TRT01AN, comma, TRT and count of TRT01AN, okay, from DM1 grew by TRT01AN. Got it? So quit. Execute. See, TRT01AN. First count is 51 and second treatment count is 49. Now what we'll do is I'll save these two particular values in a macro variable. And we know how to create a macro variable through SQL, right? I'll write another statement. Okay, so I'll just remove this one. Count of TRT01AN into. So from the output that what we have got just now, we can understand that there are only two different treatments. So which means only two different values we have to store in macro variables. So into, I'll write here macro variable names I'll give as T1 to T2. Okay. So we'll give the macro variable names as T1 to T2. So the first value will be stored in a macro variable called T1 and the second value will be stored in a macro variable called T2 from DM1 group by TRT01AN. Just in case if you want to check like what are the data values that we have in that T1 and T2, you can write like this. Ampersand T1, ampersand T2. check log. See? In T1 you have 51 and in T2 you have 49. Okay, got it. So now coming to the next one. So these two counts we have calculated, right? Now what is the other one we have to calculate? The total count. How do you get the total count? I can write in the same way, right? Count of TRT01AN into T. Okay. We no need to group the data. Okay. So just in case if you want to see like what is the total data that you have in T, ampersand, execute, check log, 51, 49, 100. Okay. So it is done. So all these three treatment values also we have calculated. Now we have to calculate the percentages. So before calculating the percentages, okay, what we do is let us stack the data sets. Why to stack the data sets? See, first you should get your age group data, then you should get your gender, race, ethnic. So this 4 looks like stacked data only, right? So let us stack that data. Okay, and remember one thing. Your treatment A, treatment B, and total, they should be horizontal. Okay, and this age cat, gender, race, ethnic, they should be vertical. So what we do is only this particular cross tabulation data we will be stacking, okay, together, and then this non-cross tabulation data we will be stacking together, and finally we will be merging, right? So you got my point, right? Cross tabulation data as in like this treatment A and treatment B data, you are for all these 4 variables you are trying to bring in one data set. Okay, and this total data, total as in like that one-way table data of these 4 variables you are going to stack into one data set. Okay, and then the final outputs you can merge together. Let us start doing the programming. Data, I'll give here it as DM. DM11 ID. Okay. Set. What other data sets do we have? These are the ones. Cross tabulated data sets are. These are the ones. Okay. Execute now. Open 1.1. See. Of course, you are getting in different columns. That is because the variable names are different, no? So you are getting in different columns. So, but according to the given report, you should get everything in one column. So how do you get that? Can I create another new variable and can I say that if age group 1 not missing, then that new variable equal to age group 1. And if sex value not missing, then that new variable equal to sex, and if ethnic not missing, then that new variable equal to ethnic. Okay, do that. I'll create a new variable. Say description. How much length that you would like to declare? Declare. So if not equal to missing, then equal to. Okay. Same way, write all the 4 other statements. Okay. Then open. See, now you drop the other 4 variables. Okay, so drop them now. Okay. So till here you got it. Now here you have the count. Now how to calculate the percentage? So less than 65 age group, treatment 1. This is 36 is the count. Okay. Now how do you get the percentage? So 36 divided by total count of the population who have taken treatment 1. So what is the total count of population who have taken treatment 1? Here we have calculated now. See, 51 is the population, right? Treatment 1 population is 51, total count. Okay. So now that 36 divided by 51. How do you do that? Can I write like this? If TRT01AN equal to 1, then percentage we have to calculate. So percentage equal to, okay, count divided by ampersand T1, because that is the variable where our treatment total count of population with treatment 1 is present. Generally, when you are calculating percentage, you should do also into 100, right? Similarly, else if TRT01AN equal to 2, then same, but the only difference is it will be T2 by 100. Now try executing and check the output. Open. We got it? Okay. So now, according to the given template, count and percentage should be together, isn't it? Count and percentage should be together. So how do you bring that count and percentage together? By concatenating. But in order to concatenate, they should be of character values. I'll create a combined value, say it as count and percentage. Okay, equal to count concatenating with percent. But they should be of character. So script. And put, okay, count. So for count, what is the format should we give? See, without any decimals, right? So the total width of the value, how much you would like to declare it. Okay, 6 I'll declare. Here also same. But how this count and percentage are divided? With parentheses, right? Percentage value should be in parentheses. Okay. So now write here strip of put of percentage, comma. Okay. Now try executing this. See, you got it. Now drop this count and percentage. We don't require them anymore. Okay, I'll just bring this drop statement down. So count and percentage. Drop it. Now execute. Check. Okay, this is done. Now here, if you observe one more thing, see, here you should get your age group data as first block. Then you should get your gender data as second block, race as third block, and ethnic as fourth block. So in order to maintain that order, what I'll do is I'll create a reference variable. Okay, I'll create a reference variable. So age group data should be the first block, right? So by using the if condition and the do loop combination, you can create multiple variables on one condition, correct? So we'll use that. I'll just create a reference variable called 1 because okay. Okay, then do end. Now try executing this. Open DM11. See, So now you can easily maintain the order, right? So age block should be the first block of data. Age group should be the first block. Gender should be the second block. What should be the third block? Race and ethnic. Why for ethnic we are getting 3? I think. Okay. So ethnic should be the fourth block of data and race should be the third block of data. See? Now you got it, right? Now here if you observe one more thing, just in case that whatever modifications or whatever customizing that you notice, make sure you do all that customizing in the beginning part only, so that it will be easy as we go to the end. Now see here, these values are not starting from the H, right? The data values are not starting from the H. So what I'll do is we'll maintain a gap. Okay. So here only I can maintain the gap, no? Like 1, 2, 3 spaces I'll maintain. I can do this so that you will get that gap. Okay. Now execute. Check 1. See, you're getting that gap now. So nice. So this is done. Now how to get this given pattern? See, treatment A and treatment B should be the headings. But here treatment A and treatment B are data values. So how do you do these two values as headers? By using transpose procedure, right? So let us use the transpose procedure. Prop transpose data equal to dm11 out equal to dm12 id variable trt01an, where which variable data values you will get transposed? Yes, NP data values will be transposed. Okay. By what variables reference? REF and description. But whenever you use by statement, you should sort your data. So sort data will be dm12. 11. Okay. By okay. Open the 1, 2. Some error is there. Let us check log. We have sorted it. CDISC. Execute now. Check 1, 2. See, we got it. Now drop this underscore name underscore. Okay. How do you drop that underscore name underscore? You can write down here, right? Drop equal to open. See, now if you check here, it's almost you got your output, right? It's like, now this total one we should get. For the total one also we'll follow the same pattern like this. Okay. And then what we'll do, this 1, 2 and that total one we will be merging together. So that you will get like in your 1, 2 you have treatment 1, treatment 2 and that total treatment also you will get it when you merge. Okay. So your part 1 is completely done. Okay. So whatever they have highlighted here, that is almost it will be done. And then what we'll do is we'll calculate the statistics for these two variables as part 2. And finally we'll stack this part 1 and part 2. We'll get the final output. Okay. So now what we should get here according to the given template. So this total value we should get according to the given template. So total is nothing but without any cross tabulation with the treatment, just finding the count for all these variables. That is nothing but the total, right? So total population with less than 65 age group, greater than 65 age group. Total male, total female. So without any cross tabulation, you should calculate the count. And we calculated that count already, isn't it? Here, right? Without any cross tabulation, only the variables count, we did it here. Now follow the same procedure as like this. Okay. Suppose here I'll give the name as DM1T. T is nothing but like total. Okay. And what are the data output data set names did we give? Age, GRP, TOT, CNT, right? TOT, CNT. So ethnic, TOT, race, TOT. And the rest everything will remain same, but here we no need this condition because we are not doing any cross tabulation. So if you are, when you are doing the cross tabulation with the treatment, then you should write this condition, but now it is not required. Anyways, we'll do till here. Let us execute. Check 1T. See, you got the count. So less than 65, greater than 65. Only female, only male. Only Hispanic, only non-Hispanic. This you got it. Now you have to calculate percentage. So now here we have calculated the total count of the population and saved it into a macro variable T. Right? So now percentage you will be calculating equal to count into ampersand T into 100. Okay. And what will be the combination? It will be the same, right? I can use the same formula like here. Count and percentage. Now, along with all these variables, you can also drop count and percentage. Drop it. Now, execute this one. Check 1T. You got this count percentage. Okay. So this is nothing but total, isn't it? So can I rename this NT to total so that we can easily understand, right? I'll rename NP to execute now. Check. See, we got it. Now we'll merge these two data sets, this 1, 2 and this total. Okay. We'll merge this two data sets. So on what basis you can merge the data? DM1. Can I take like DM1 final? Merge which data sets? DM1 to DMT. Correct? By what variables? Difference and description. Now we have to sort our data, right? Cross data equal to okay. Now execute, open if final. See, 1, 2 total, we got it. So part 1 is like 90% done. Still we have few more things to do, like the inserting the headings, right? Before 65 and before 65, greater than 65 and less than 65 data values, you have to insert age cat heading. Before male and female, you have to insert heading gender. Before race, you have to insert heading, before this white, black and all these data values, you have to insert heading called race, and Hispanic, not Hispanic, heading ethnic. So how to insert those headings? Can I use proc SQL for this? Proc SQL. Insert into, okay, insert into final. Then I'll use value statement, okay. For which variables do we want to insert? Difference and description, I'll say. Okay, values. So Here for less than and greater than 65, what is the reference value do we have? 1, right? So since we have to insert that age cat heading before 65, less than and greater than 65, I'll give the reference data value which is less than 1. Okay, so that when you sort your data, you will get in the correct order. Okay. Any value you can give. I'll give 0.5, which is less than 1. Okay. And what is the heading should be? Age cat is the heading. Right. So this is done. Similarly, I'll write like this another 3 value statement. I'll write 1.5, which is less than male and female. For male and female, the difference is 2. So less than 2, I can give any number, right? Less than 2 and greater than 1, I can give any heading, any value. And what is the heading should be? Gender. Okay. Give gender. Then 2.5 and 3.5. Following the same pattern. Race. What is the next heading that we should give? Ethnic. Heading is ethnic. Is done. Then right click, insert into DMF. Yeah. Execute now. Check DMF. See, now you sort your data by reference. How to sort our data? By see. Okay, so just in case if you, anyways, these 3 belong to one block of data only, right? And these 3 belong to one block of data only. So rather than taking like 0.5, 1 and 1, if you want, you can round the values. Okay, so how to round the values? You can take a data step. Data set TMM. Okay, what's that value? Execute. Check. See, it's very nice. But I mean, we got a perfect output, right? Like whatever they have given in the template, according to that, we got the output. Right? So here your part 1 is done. Okay. Now let us do your part 2. Okay. Let us do part 2. So in order to do that part 2, first let us take an example. So why we should take an example here is, now see, so they are asking you to calculate the statistics for age variable classified by treatment. Okay, for treatment A and for treatment B, they are asking you to calculate the statistics. That's good. Now here they are also asking you to calculate the statistics for the total as well, right? Like without classifying by treatment, you have to calculate the total also. Let us take a small example here. Data. I'll create a data set called test with variables. Say input store sales. Okay. Cards. Suppose say store 1. Say the sales are 20. Store 2, 34. So 40. Store 1 again, same 15. Again store 1, same. Again store 2, same. Okay. Actually, this is how our data is present, isn't it? Open DM1, original data. See, how you have your treatment values? Either 1 or 2. So treatment 1 or treatment 2, correct. So the same in this pattern only we have our data present. Now, same question, like suppose say you have to here calculate store 1 sales, store 2 sales, and then total sales. Store 1, store 2, and total sales you have to do it. How can I do it? Can I write proc means or proc summary? Any procedure I can use, right? Go to test. So classified by store, because we want store 1, store 2, total sales we want. Okay, where sale. Which stat we want, whatever stat that we want, we'll write it here. Sum we want. Now execute. So here you are getting store 1 sales, you are getting store 2 sales, you are getting. But what about total sales? You are not getting total sales, right? That is because whatever data that you have in your classification variable, for that each unique value you will get the statistics, but not for the total. So now in order to get the total, what we'll do is I'll duplicate the data. So same data we are replicating in the data set. Okay, like this. But not with the same store value. Store value we will be changing to 3. Like any value of your choice you can give. I'll change it to 3. Okay. So now if I execute this program, so store 1 is store 1 sales, store 2 is store 2 sales, store 3 is nothing but total sales, isn't it? Did you get the logic?
Yes, fine.
Okay, good. Now let us apply the same concept for our data. So same concept we are applying for our data. Now data, we have a data set already DM1. I'll create a data set called DM2. One is there, no? Yeah, DM2. Set from DM1. Whatever data we have in DM1, that we want to copy into our DM2, right? So that treatment 1 and treatment 2 data, like all the data will be copied, right? So out of this 100 observations, according to the count that we have calculated previously, see, 51 is treatment 1 and 49 is treatment 2. So that count you will be getting. Right? So write output. In order to get the total treatment statistics, TRT01AN equal to, I'll write it as 3. Okay. So that, and in this case also we want into output data set. So what happens now? Whatever 100 observations that you already have, again that 100 observations will be replicated into the same data set with TRT01AN value as 3. Okay. Now execute this. I'll sort the data so that you can easily identify rock sort data equal to okay. Now open DM2. You got all your treatment 1 data. You got all your 2. So 1 and 2 will be 100 observations. Right? So now okay. So now see here. 3 is nothing but combination of 1 and 2, all the data. So now when you write, whatever procedure that you would like to use, either means or summary. Okay. So summary data equal to DM2 okay. By TRT01AN where for which variable? Age is the variable. Okay. Output. I'll create an output data set. Okay. Equal to age 1. What statistics do we want to calculate? According to the given template. N, mean, median, min, max, standard deviation. Okay. So N equal to, I'll give a variable name as, okay, N, mean, median, minimum, maximum, standard deviation. Okay. I'll give, like we have to give the column names in this procedure, right? So I'll give it as mean, median, mean as underscore mean. So why I'm giving here underscore is, so within one modifier, you can drop all the variables that are starting with underscore. So I am giving here underscore, okay? A variable name I'm starting with underscore. So underscore std. And then now execute this and check age 1. See, but now here you upload your template. Okay, min and max are together, like separated with comma. Okay, so now here itself only I can combine that min and max, right? We'll take a data step. So, age 1, no? Our data is present in age 1. Okay, set from age 1. Now, min underscore max equal to underscore min concatenating with underscore max. But when you are using concatenation operator, it should be a character data. Okay. So strip put comma without any decimals, right? According to the given template. So without decimal, how much did we declare? Width 6. Use that. Then here also I can do the same. Okay. Execute and see. Open H2. See. Okay. But we should separate them with comma, right? Okay, this is done. Now, here if you observe one thing, see, as of now you have all these values as different variables or different columns, but finally you should get all of them under one variable, isn't it? So when you want to place all the data into one variable, it means all that value should belong to the same data type. So in order to bring them under the same data type, I'll apply the same formula for all the variables. Underscore n. Okay. I'll create the variable as n. Okay. Then just leave this part. After n, mean. Then mean. After mean, median. Okay. After that, min max. After min max, standard deviation. Underscore. But for standard deviation, they are saying they want with 1 decimal. So, okay. Now execute. Open H2. See. N, mean, median, min max, standard deviation. So now I can drop all the variables that are starting with underscore, right? So that is the reason why here I have given underscore when I'm giving the column name. Okay, so that all the variables starting with underscore you can drop at one shot. So how you can drop is drop underscore column. So by using this modifier underscore and colon, you can drop all the variables starting with underscore. Open H2. See? No. Now here, according to the given template, you should get all this as data values. As of now, you have as variable names, but they should become data values, right? So how to bring them as data values? Transpose procedure. Proc transpose. Data will be age 2. out will be age 3. Where which variable data values will be transposed? N, mean, min, max, these all the values, right? Mean, min, max, standard deviation. Okay. By what variables? We have only one, that is DRT01 AM. And run. Open H3. Open H3. No. Sorry, not by. Here it should be ID, isn't it? Because see this, whatever treatment values that you have, those values should become the column names, right? See, whatever treatment values that you have, they should become the column names. So how do you convert a data value into a column name? By using ID statement. Okay. See, now you got this. This 3 is nothing but total, isn't it? So if you want to rename, you can rename it so that it will be easy for you to remember. Okay. Okay. Now let us transform the data further. Here, see, they're asking you min, comma, max and standard space deviation. But what is the data value do you have here? Min underscore max standard underscore deviation. So let us convert that data values. Data, I'll create a data set called age 4, set age 3. Okay. So if underscore name underscore equal to, what is the data value? N, right? And why I'm taking this N is then I'll create a variable called description. What is the length that we have defined for that variable initially? Same length you carry out throughout the process. Description equal to 1, 2, 3 and then I'll give N. Okay. Because see, it shouldn't, the value should not start from the age. We should leave some spaces. So how many spaces did we leave before? 3, right? So here also I'm maintaining the same 3. Same here in the next statement. Else if equal to main then main. Else if median, then median. Else if min max, min max, comma max. Standard deviation, okay. Okay. This is done. Now we can drop our underscore name underscore, right? Drop it. Now execute this. Open 4. See? Okay. Close it. So this is done. Now almost we got it. Suppose if you want to rename, you can also rename that underscore 3. So rename underscore 3 to total, just in case if you want to. Okay. Try opening age 4. See. Okay. One treatment 2 total, and this one you got. Now here you have to insert the heading, right? This age heading you have to insert. I'll create a data set called test. Okay. Then description equal to, I'll give this age. But whenever you are using that variable, make sure you are using the length as well. Okay. Now open test. This you got it. Now I'll stack these two data sets. Age 5. Okay. Set test age 4. Run. Okay. Open 5. Got it? So yours is almost done. Now if you would like to, I'll create one more variable, okay? Because that age is the 5th block of data in the report, right? What is the reference variable did we create before? So 4 are done. Now age will be the 5th block of data. So I'll write 5. Open 5. Now in the same way, same programming you do for your platelet count, because for platelet also they are asking the same, right? Only just the change in variable name. So what we'll do is from proc summary copy. Okay. Now platelet, what is the variable name? PLT CNT, correct? PLT1. So wherever you have that age, just replace with platelet PLT. Okay. Here the heading should be platelet count. That's all. Did we replace everywhere? PLT5, PLT4. Yes. Execute now. Open PLT5. See? What you are. Now you stack all these data sets to create your final. Okay? So, data. I'll write final. Set. What is the very first one that we have? DMF, right? The other one, age 5. Then PLT5. Open that. See? You got it? Now generate a report through proc report. So proc report data will be final. Okay, and run. Run. I'm sorry. Save it on desktop. Save. Okay. Now run. See? Okay. But we have to do slight modifications, right? Just remove all these default features, because no default features you have in the report, no? So just remove all of them. How do you remove that? Options, no date, no number, no title. Good. So now, so what title do they give? This is the title, right, that they have given. Take this one. Okay. I can write title 1 actually. Title 2. See, got it. Now, after that, you should get these lines, right? So how do you get that lines? I can write column statement, okay? Column here, and here we should write headline. And what are the variables we should get? This one, okay? So REF, DSC, score 1, score 2. See, got it. Now we don't want refer. Okay, so you have to order this data. Okay, ordered by reference variable. Okay, so define reference order. Okay, and then define description. So why I'm giving here empty space is because see you doesn't have any heading here. Okay, so that's the reason I'm just giving empty. I'll reduce the width as well. Okay, 30, because see here it is occupying lot of width, right, unnecessarily. So just reduce the width, 30. Okay. Try executing this and see. Cool. It's not. No, it's not nice. It's here the heading is getting cut. Executing. See. No, still something is getting. Let us do 40. Now it is good, right? Now, so here if you observe, like after every reference, after every block of data, you are getting a blank space. How do you get that blank space? Break after, okay? Break after reference. And we want a blank space, go skip. See, you're getting it, okay? Now this 1 and underscore 2 should be treatment A and treatment B, right? So define underscore 1 TRT A. TRTA, and then see below to the TRTA you should get the count, right? So dot how much is the count for A? 51, right, according to the calculations that we have done. And I'll give here select equal to dot. So the TRTA you will get in one line, n equal to 51 you will get in the other line. Okay, not TRTC, it is total. Got it. Now this REF we don't want to print, so no print. After that, in the end you have to give a line. That's all, right? Just everything is done now. This here you just have to give a line. That's all. Okay. Yes. So compute after, okay, line starting at what position? 6, 7, 8, 9, 10, 11, 12, 13. So could be like starting at 14th position. Say some 60 lines. Say some 60 dashes. And the comma. Wait. Different position. Season. Okay. This is also done, right? Just cut down the extra ones. Okay. Okay. So your report is done finally. So however they have given for you in the template. So following the same pattern, you have generated the report with the given data. So now export this into PDF. You know how to export that into PDF, right? How to export? ODS. ODS PDF file. PDF or RTF into whatever source that client requests you to give you the output. Give it according to that format. Okay. I'll save it on desktop. Okay. Then report.pdf. Whenever you open a ODS statement, you have to close it after we are done. So PDF close. Check log, there is some error. The component of, so when you get this kind of error, which means SAS is taking the path from here. See, I'm just doing the spotlight. So SAS is taking the path from here. So in this case, what you do is, instead giving the path in your program, I mean in your ODS statement line, instead giving the path, you give that path here. Since SAS is taking the path from here, just double click over that path and where you would like to save on desktop, click on OK. Now execute. No. Yes, it is printed. Check. See, you got your report into PDF. Okay. So this is how you can generate your tables.